Hello everyone, my friends, my viewers at home. My name is Andrea Lane, the Biological Prophet, and today we'll be talking about a very interesting video in chemistry, which is called Resolution and Theoretical Plates in Column Chromatography. So, our interest in this video is to talk basically on the calculations that are involved in column chromatography. And before we continue on the calculations that are involved, we should understand that first of all, that chromatography is a separating technique which involve the separation of mixtures by distributing its components between two phases, and that the two phases include the mobile phase and the stationary phase. Now, the stationary phase remains fixed in one place, while the mobile phase carries the components of the mixtures through the medium that is being used. Take note of these two points, which is the stationary phase and the mobile phase. Now, our interest now is now column chromatography. Now, in column chromatography, the stationary phase is packed in the column, while the mobile phase is a moving liquid or a gas. Now, we move straight down to resolution. Now, what's resolution? Resolution is a measure of how well two elution peaks can be differentiated in the chromatographic separation. And do not forget that there are some terminologies that are used in column chromatography, which we may not have enough time in this particular video to talk about them or discuss about them. Some include the flow rate, the effluent, the effluent, as the case may be. So in our subsequent video, we'll talk about them elaborately. Now, we'll move straight away. We can also define resolution as the difference in retention times between the two peaks divided by the combined width of the elution peaks. So you see that some things that you should take note here, which are what we call the retention times and peaks. And on the board, you are seeing the formula of resolution. The formula for resolution. The formula is equal to the retention time of the second eluting peaks minus the retention time of the first elution peak divided by the baseline width of the second eluting peak plus the baseline width of the first eluting peak over 2. Now, this, what you are seeing here, is also equal to this, which is also equal to this, which is 2 retention time of the second eluting peak minus the retention time of the first eluting peak, as the case may be. But do not forget that resolution is proportional to the square of the number of theoretical plates. Take note of that point. And on that note, we move straight down to what is a theoretical plate. It is symbolized with N, and that a theoretical plate measures how efficiently a column can separate. Look at it. How efficiently a column can separate a mixture into its components. And on that note, we can establish the fact that a theoretical plates estimate the efficiency of a column, and the formula for theoretical plate is equal to 16 multiplied by the square of the retention time over the baseline width. Now, we could also understand that H, which means the plate height or the height equivalent of the theoretical plate, which is, in fact, as you can see right on the board, the abbreviations for this formula is what you can see, whereby H stands for plate height or the height equivalent of the theoretical plates, and N the number of theoretical plates. And we'll move straight down to a good question on the board. And the question is, in a chromatographic analysis of lemon oil, a peak for lemonade has a retention time of 6.9 minutes and a baseline width of 0.88 minutes. Typings elutes at 8.36 minutes with a baseline width of 0.64 minutes. Question now comes in. What is the resolution between the two peaks? And do not forget that the formula is resolution is equal to 2 from the formula here, rotation time of the second eluting peak and rotation time of the first eluting peak over the baseline width of the second plus the baseline width of the first. So we should bring out what we were given from the question. And from the question said a peak for lemony has a retention time of 6.9 minutes, which is for the what now? Which is the TR1 to be 6.9 minutes. And at the baseline width of it, which is the baseline width of it, was what? Was given to be 0.88 minutes. So we move to typing, which is between limonene and typing. So WB2 for typing is 0.64 minutes, and rotation time of the typing, which is the TRO2, is 8.36 minutes. So the formula is equal to 2 bracket 0. Okay, which is okay, that's 8.36 minus 6.9 over 0.64 plus 0.88. When you do it, your final answer should be 1 point. When you do the mathematics, 1.92. Now, in our next video, we'll move ahead again to other calculations that involve the plate heights. For now, God bless you and